How are we doing today? After lunch on the first day? My name is Spencer, and I will be talking to you today about .NET Core, a little bit of .NET Framework, because that's the world I live in, and running background tasks, and all the different ways of creating, hosting, you name it, all of the kind of like a general overview of kind of the constructs that are available in .NET Core and other frameworks, or .NET Framework, really. So first start with the QR code. This will be a link to the slides and also the code. I will show this at the end too if you don't want to take a picture of it now or open it right now, but if you do, you can follow along with the code examples if you have a laptop. Real quick before we get started though, anybody first time to DevConf? First time? Okay, a few of you. Cool, very good, very good. And how many people, I assume you all do .NET Core to some degree. I'm curious to know if anybody in the audience does .NET Framework stuff, web forms, any of that goodness? Yeah, that's the good stuff. That's the good stuff. I'll be touching on those because, like I said, I own a software consultancy. I didn't say that yet, but I own a software consultancy, and as part of that, part of what I have to do is deal with legacy systems. So we'll definitely talk about that, at least to touch on it as well. And I wanted to give this talk for a few reasons. First of all, background tasks have kind of evolved and changed over the last several iterations of .NET. Back in the .NET Framework days, you would host on Windows, and you maybe have a Windows service or something that runs in Task Scheduler, something along those lines. So the constructs, the stuff that you get baked into .NET Core is a lot better. And plus, I find this topic to be interesting because we all have processes that have to run either routinely, they have to run every day to send in emails, invoices, whatever the case may be. And so this is kind of a good general way of touching on the strengths and weaknesses of all the different kinds of constructs that are available to you as a .NET developer. So a few talking points. We'll be talking about the various background runner options that exist for .NET Core, of course, Framework, as I mentioned. We will talk about the strengths and weaknesses of each. And what I do in the real world. So as I mentioned, I have about, I'd say 6 or 7, I think 6 or 7 active customers. All of them .NET, all of them but one .NET, no, 2 .NET in some way, shape, or form. And even then, even the ones that are not .NET, I take some of these lessons and apply them to on the AWS side in this case. Worth mentioning that we will be talking about a lot of the hosting options in Azure specifically, because for some reason, .NET devs just seem to always be like towards Azure. I'm not really sure why that is. Maybe it's that Microsoft thing. But it's what I use and what I know. But there are analogs, and most of the stuff translates to different services if you use AWS or something similar. And finally, we'll talk about how I monitor these tasks and how I make sure that they are running. So let's talk about what background tasks are generally for. Background tasks are like routine jobs, like a daily email or some kind of process, some kind of payment process that has to run to get payments from a payment processor and import them into your system. That might run every hour, it might run every day, but it's some kind of background process. It could be some kind of background process that runs as a sort of like a batch job is a kind of a legacy term that I hear sometimes, but something that runs routinely that is often business critical. Something relies on it. We all have jobs like this. We all have something that runs like this in our day-to-day. Long-running jobs, specifically where returning synchronously doesn't make sense. Like think if you were clicking a button in a web app and you were importing a million rows from a CSV, you're probably not going to sit and wait for that web request to finish. You're not going to import the spreadsheet and make the user wait till the web request finish if you're importing spreadsheets like that with any amount of frequency. You're probably going to kick off some kind of thing in the background and say, hey, when we're done, we'll let you know, but we're just kicking this off and we're making this work right now. Might be triggering a process that takes lots of compute. This is something that I deal with a lot, and we'll talk about one of my customers specifically and how they've kind of scaled how they run background tasks, as it were, from 3 years ago when they first started with Azure Functions all the way to going up to Kubernetes, and we'll kind of touch on that kind of case study as it were. Yes, and in a web app, specifically in a web app context, and I mostly talk about web apps because most of the stuff that I do is on the web, you probably don't want to use you don't want to do a CPU intensive task inside of the context of your web app, because then you risk interfering with like the web requests that are coming in. And so you don't want to take those down. So you might find a process that we've all encountered something where a process just takes way too much CPU time, degrades the performance of the rest of the app, response times or what have you. and then you just have to move on. As you scale, you have to move that process out. So we'll talk about that. So there's lots of options all the way down from the build it yourself kind of thing, all the way up to something that's more batteries included. The build it yourself, first construct that we'll talk about is iHosted service and task scheduler if you were running in Windows and running as an executable or a PowerShell script or what have you. A construct called BackgroundService, which is a construct inside of .NET Core that I use frequently for running background services. And, and worker service, which is a .NET template, and we'll kind of just take a peek at that. We'll take a look at that code and see exactly what it generates. We'll go all the way up to batteries included stuff like HangFire. I specifically talk about HangFire because it's the most popular one. It has been around for a very long time. It has been around since the web forms days. I know there are others like Quartz. I don't touch on those because I've just simply never used them. But if you use it and you love it, great. But I don't have time for everything, as it were. And then we'll talk about cloud options like web jobs, functions, and container stuff, either Kubernetes or Azure Container Services, container apps. So a lot of these things are going to look very similar. The code is going to look very similar for most of these background services. They're just very simple, basic examples that don't actually do much except log to a console, right? A lot of the questions that are going to come up as to what construct that you end up using inside of your day-to-day is really going to come down to ease of deployment, scalability, and the dynamics of your team. And we'll talk about that. I recently had a client engagement where their team they're still on web forms. They do AS.NET Core stuff for APIs, but they were really uncomfortable with this idea of kind of message-based systems. So there were some things that I did to kind of ease them into, okay, how do you kick off this back-end job to do something? And we'll talk a little bit about that. My most important considerations when I look at a particular process where it's being hosted is going to be one of four things. It's going to be reliability, it's going to be observability, it's going to be observability, and it's going to be observability. And specifically, observability is the way that you measure reliability. And so a lot of frustration comes around not being able to see what a task is doing. So in order to measure its reliability, you have to be able to see what it's doing. Anything that makes the background task visible, whether you're logging to application insights or something like Datadog, whether you're logging to a text file, or showing to some kind of stakeholder or some kind of person who might own something related to that process that, hey, the process worked, or hey, the process didn't work. Some way of saying so that there's some kind of check and balance to make sure that the process ran. And the importance of visibility is really directly proportional to the process's importance to the business. Recently, we had a situation where we had an hourly batch job that would run and import payments for a payment processor. That process was really business critical, and what was happening is that there was a failure. I mean, it's pretty typical, you've heard the story. There's a failure on the API services end, and the ability and knowing that process was down was really important so that we could come up with an alternative to get those payments into our system. The more business critical the process, the more observable you should make it. Reliability is, of course, important, but without observability as a means of measuring reliability, it becomes difficult to see that a process is running and for stakeholders to have trust that that process is running. Lack of observability on business critical processes like background jobs is a huge source of frustration to stakeholders. You would not believe the number of times, and I'm sure you all have heard the same thing, where you've been in a meeting and somebody has said, well, you know, this process was supposed to run. It was in task scheduler, it was supposed to run, but it's been failing the past 4 days and nobody knew anything about it. And it just so happened that people weren't getting an email or some kind of notification, right? It could be simple stuff like that, but we've all encountered problems where, somebody, whoever owned it just didn't notice because they don't check it routinely that suddenly it stopped working. So the ability to observe those background tasks is really important. And we'll talk about we'll briefly touch on some constructs that exist in .NET Core that can help with that. So let's start with task scheduler. This is the most basic thing that I've done, and it's because I still do a lot of, I live in the cloud a lot, but I still have to manage VMs because going to cloud native stuff like Azure App Services often doesn't make sense for certain clients. So it's better for me it's oftentimes they're still on VMs for some reason, and because I work on legacy systems, oftentimes I have to worry about task scheduler stuff that's just hiding in task scheduler. And of course, there's an analog for Unix systems as well, cron jobs. This is a .NET talk. We'll just focus on Windows. Same thing applies, though. This specifically, so this is just a list of just generic ones that were added by like Google Update. But we've all seen a situation where somebody's got an executable, something that runs. Maybe it cleans up some data or invalidates a cache, something that runs on a routine. And this last run result is like the bane of my existence. And the reason it's the bane of my existence is because oftentimes it'll say the operation completed successfully, which is great. But oftentimes, task scheduler will just return some kind of cryptic, weird thing. It's like, well, it kind of ran. What does that mean? It kind of ran. Like, I don't know. I have a lot of frustrations with task scheduler. So for the most part, and there are tools that you can download, third-party tools that you can use to watch scheduled tasks and watch them run. That's more than I want to take on typically, unless there's a ton of them. But more often than not, what I will do is I will, especially when I'm migrating a legacy system, I'll keep the task scheduler stuff, but I'll go to the Jira board and I'll add a backlog item, probably one that won't get worked on anytime soon, but I will add a backlog item to actually go in and clean that up later and move it out of task scheduler. Because you have to build in your own observability, right? You have to put in your own logging. That logging has to sync someplace. You have to make that a concern of the application, which is true for most things, but if the scheduled task doesn't run and nobody's notified, that can kind of suck. So for new stuff, I avoid it like the plague. And for legacy systems hosted on VM, I will use it, but like I said, I plan to move on it later. I have to mention this one because this talk is a little therapeutic for me, and fighting task scheduler is something that I have to do from time to time. So let's actually move on to things that are, I guess, a little bit more modern, and we'll start with iHosted service. So this is a basic building block for a service that is written for .NET Core. And it's an interface, and it has two methods. It has start async and stop async with a cancellation token. That's pretty much it. Anytime you make a call to add hosted service inside of your web application, oh, look, some code. That's pretty nice. Anytime you make a call to add hosted service, if it's some kind of, even if it's a background service, spoiler alert, background services are iHosted services, or whatever the case may be, it just has to be a service that implements iHosted service. And so here's an example one that comes from the Microsoft Docs. Of course, the Microsoft Docs are awesome, and so there's just a link down here if you want to go see a little bit more information. But this is one where they just simply start a hosted service by firing up a timer, and then the timer just routinely triggers a function. So, yep, there we go. So these are the implementations of those methods. Very simple. Logger to say that we're running our service, and then return to completed task, and set up our timer, of course, to actually run every 5 seconds starting immediately. And then we do have a stop async to turn that timer off by taking its timeout to infinite, which is effectively, well, it just shuts it down, period. And it's worth noting as well that this method, this start async method, will block startup of your .NET Core web application. So if you're doing a lot of stuff inside of this start async method, you probably shouldn't, or you should start that process. You should kick off some other asynchronous process and then return as soon as you can, because this will actually block your application from starting up, which is not ideal. I do want to give a shout out to System Threading Timer, which is a little different than, if you're not used to using that, than system.timers.timer, which should almost never be used. My main gripe with them, I've actually encountered this recently with a third-party library that I consume. They use system.timers.timer to trigger some kind of process, but it just so happens that an exception thrown inside of a delegate that timer fires off will crash your application, which is really awesome. No matter what it is, you have to handle it or the application crashes. So that is essentially iHosted service in a nutshell. Not a lot to it, very simple interface. Now, what do I use it for? I don't use it. I don't use it directly anyways, which we'll get to the background service thing here in a second. But for .NET Core itself, for the library itself, it's a great building block. It's a necessary building block. But for me, us mortals, I just don't use it directly. There are plenty of better abstractions, which we'll see right now, in fact. Background service is probably the one that I use the most. It is .NET Core's opinionated way to run background services. Already, as I mentioned, it already is an I-hosted service. And if we take a brief look at the source code, you can see that it's super simple. I have internet, right? Awesome. Okay. It's super simple. You see that it's, oh, that doesn't help. How about that? Woo, there we go. Okay, you see that we implement I-hosted service as promised, and then we basically, you define your execute async task here, and then it basically just stores the task that you've defined in execute async. It stores it locally, it takes a reference to it, and then when the application is requested to be stopped, it will then pass that stopping token, that'll pass that token along to your execute async delegate. And going down, you can see that it's honestly pretty straightforward. There's, I think, yeah, altogether it's less than 100 lines of code. And so this is the basic abstraction for I-hosted service, and basically what most people should be using pretty much when they're doing background services. Here's a super simple example of one. You can see here that I've defined an execute async method that has a while loop. While stopping token is cancellation requested, I'm going to do some kind of process. It could be importing payments. It could be sending out emails. Doesn't matter. And then I'll just await task delay in order to, well, in this case, run it every second. But you could have a process that runs every hour or whatever the case may be. Fair to say that catching exceptions inside the while loop is important because an exception thrown will just take the background process down and won't start it back up. But you would know that because, of course, you're going to add observability to it, right? Right, of course. So how do I use background service? For straight, small ASP.NET Core apps that need some kind of routine thing to do, I use it quite a bit. I enjoy it as a very quick way to add a background service to a web app. I'll usually flip it to always on to make that web app to always on to make sure that it always runs, either in IIS or Azure, one of the two, to make sure that it stays online so that it actually does the work that it's supposed to do. And that's the point I want to make, gets to the greater point that I want to make, that it is beholden to the whims of the app that contains and owns that background service. Because if it's a web app, it will shut down when the app shuts down. Pretty simple. When it'll shut down if the app crashes. Of course, that makes good sense. It can contribute to and be affected by performance issues. Contribute to if you're doing a lot of CPU-intensive work inside of that background service. Especially if it's affecting the remainder of the rest of your application, it might be time to move that out. We're actually I have a client right now where they have this PDF generation tool that they have. And they're still trying to get market fit going, so they don't want to move the background process that runs inside of ASP.NET Core, in this case web forms, but they need to because it's actually affecting the performance of the rest of the application, kind of a chicken and egg money problem. So it can become difficult. So CPU-bound stuff really doesn't belong in background service, period. And then, of course, configuring the app to scale out. If you have your Azure App Service to automatically, elastically scale out horizontally as traffic comes to your web app, you're going to get multiple background services. Now, can you do some funky stuff like lock them in Redis or something so that only one runs at a time? Yeah, you could do that, but at that point, it's probably just better to move it someplace else. And of course, observability has to be built in. You have to log things to your logging system in order for any nuanced part of that process to run and to be observed by somebody. You still have to log it out. Pretty typical for anything else, but worth saying. It doesn't have like a built-in health service out of the box where you can just say, hey, how's this background service doing? We'll go over a really simple example that I have in code a little bit later. Examples forthcoming. So worker service is a project template in .NET Core, and it pretty much just comes with an example non-web app. It's basically just the generic host running a very simple background service. It can very easily be added as a Windows service or systemd process if you wanted to. And out of the box, it's pretty much same as any other .NET generic host. It just doesn't have web stuff, and it just has a background service running and associated to it. Let's go over a little bit of that code briefly. Let's see, I gotta move my Writer instance over. Anybody use JetBrains Writer? Just out of curiosity? That's the good stuff. I'm not as much of a fan of Visual Studio anymore. So I'm going to move it over here, and that comes up okay. So I am going to minimize it over yonder. Boom. And then I'm going to go over here, and I'm just going to show you the one that was created, worker service right here. This is one that was just created straight from the project template. Let's go ahead and zoom that in. I think I have to scroll zoom. Yeah. You can see, whoa, it's a generic host, and in their configure services call, they add a hosted service. So crazy, right? And then they build it and run it. Pretty typical, straightforward code. So, I mean, if you wanted to have something just out of the box and you knew that you were going to go to a service, yeah, you can go to File, New Project, and go to Worker Service and create a worker service. There you go. It's available to you. Here's one that I have that is added as a Windows service. So I throw an exception if it's not Windows, but if it is, then I come down here and I'm able to define the service name and whatever the run as properties or whatever the case may be. And then in this case, also registering it so that it logs to event log, which can be useful if you're on a Windows machine and you love event log. There you go. You can log it to event log pretty easily. Not a lot to it. I can't run it, of course, because I'm on a Mac, but that's pretty much all worker service is. Again, it's really just a project template and not much else, which is just fine. I gotta find my cursor here. There we go. Boom. How do I use worker service? So the work that I do is either really legacy, it seems, so I'm already working with existing services and looking to migrate them away from being Windows services, or I'm working in kind of microservice-y, message-based architectures where I simply just don't have a use for something like worker service because it's mainly just a non-HTTP generic host. And I like the HTTP part, right? Having an HTTP host, having something be hostable in HTTP is super cheap, right? You get a URL, all you need is a URL, and then you can just start sending requests to it, right? And specifically for health monitoring purposes, I really like having an HTTP service. So most of the time, if I do start with something like this, if I'm not planning on containerizing it, I'll just start with the generic web app. I usually don't start with worker service. So it's either it's either a background service inside of an existing ASP.NET app or just a special purpose, something that's either kind of a container, an app that's going to be a container that's going to handle some messages coming in, something along those lines. And Top Shelf. Anybody here heard of or used Top Shelf? Okay, so I got one hand. It's kind of it was back in the day, back in the .NET Framework day. It was a great way to create Windows services. It kind of took away some of the complexity of creating Windows services. So strangely, I don't use worker service because I just haven't found a need for it. But I do use Top Shelf because those are the kinds of services that I had once upon a time. So quick shout out to Top Shelf. It is still something that I do use, mainly because there's been no need to refactor away for it. Always something different to do, right? I had technical debt. It can get cleaned up later. HangFire. Now, I'm curious to know, anybody in this audience used HangFire? Okay, quite a few of you. So HangFire is the kind of the batteries included solution, especially if you're doing .NET Framework stuff. Like, it has been around for 10 plus years. Scott Hanselman used to write about it on his blog. If you Google Scott Hanselman HangFire, there's blog posts over 10 years old just talking about integrating it in a .NET Framework app. Back then, what was .NET Core? It didn't even exist. I think it did maybe 10 years ago. I can't remember exactly when it was born, but never mind. Out of the box, it has some goodness. It has a lot of goodness, including a job dashboard, job storage. It does have concurrency management, and it is free for commercial use, and they do have commercial support, which is something that if I'm consuming a third-party thing that's kind of out of the box and turnkey like this, ideally, it's for procurement, for the ease of procurement. It doesn't cost anything. I know that sounds a little open source entitled, but for the ease of buying or acquiring something and using it, always helps. But I often will go for something that has a commercial support option because I want to be able to ask questions if I'm really relying on this thing. So if you've never used HangFire before, let's do a quick demo of it. I have something here in my little code. Let's see, get my cursor over here, boom. There's like a little delay on this thing. So let's go here, and oh, I already got HangFire selected, so we'll go run. And it will open a dashboard. So I'm gonna look back at the code just really quickly. and show that there are things that are defined for this particular service. I have a, so it's pretty much a generic, I'm going to minimize this so we can see the code a little better. So, like most things, it comes with a call to add services to your iService provider to add the HangFire service to it. In this case, I'm just using the in-memory storage. For production purposes, you would use something like SQL Server, which I think is one that they provide for free. I think there's a community-supported Postgres one. And there is a paid, if you do their HangFire Pro, you can use Redis as your backing store. But usually I'm just fine with SQL Server for what I'm running it on. But if you really need that intense high performance, Redis would be a good option as well. So add HangFire server, so that way we have something to the platform to execute on. We have our long-running background process here. Notice that I'm not calling to add hosted service because I'm actually having HangFire executed. So I'm just adding it to my dependency injection pipeline so HangFire knows how to construct it. Because I am going to come down here after we build our application and actually start to put into it what we're actually going to respond to when we make HTTP requests. We first start with use HangFire dashboard. I'm just having it be at the root because it's super easy that way for demo purposes. And then for our recurring job, we have a couple. We have the recurring job ID, so something happened. And this one is simply just a, excuse me, let me get this out of here, a method call to console.writeLine, and I have it set so that it runs every minute. And I have the same one. This one's sort of just an inline method call to console writeLine. And then this one is actually getting a copy of the service and actually calling do stuff async. So when we go over here, it's been running for a couple of minutes now. You can see you get this graph of all of the executions that have taken place and whether they were successful, failed, or not. You can look here under recurring jobs. You can see that something happened. So we have the actual job, and we'll look at this real briefly because I think it's kind of interesting how HangFire does its work. And then we have our long-running background process here. So that's good. It has built-in retry, so if a job fails, it will automatically retry a few times because of some kind of transient error, whatever the case may be, and then it will just straight up, kind of like a message queue, it'll just straight up go into here and just say, hey, this job failed. And then, of course, there's just the regular, quote-unquote, jobs that might be triggered from an HTTP request, something that's not recurring, something that, say, just fires off some kind of process that, again, might trigger a process that imports 1 million records from a CSV. That kind of thing. And you can see we have a log here of all the ones that succeeded. So all of these jobs have triggered, and they're stored. They have an individually assigned job ID, and we can look at them and see the name of the job, as well as some of the parameters that are used to invoke it. And that in particular is kind of interesting, because if you go here to the code, you see that this method call is not a func, it is actually an expression. So one of the things that, so if you look there, you see that it's actually not calling this function, it's actually directly, it's actually breaking this expression tree down into its component pieces, serializing that, and then putting that in its backing store to say, okay, this thing needs to be triggered down the line. We will then build that expression back up, using whatever their compiler is behind the scenes. We'll build that expression back up, and then we'll invoke it with those parameters. And that, I believe they do that because it gives you some kind of, gives you some ability to retry jobs very easily, because you're just calling a method, right? You're calling a method with maybe a set of parameters, but you are calling a method. And that's interesting because as soon as you try to do something like boom, boom, it's going to complain at you and say, hey, I can't make a multi-line expression like this. So a little bit of behind the scenes on HangFire. That is HangFire. Switch back to the slides here. Good stuff. Okay. How does Spencer use HangFire? Oftentimes, if I've inherited a legacy system where there's, as I keep mentioning, web forms. Like I said, I still do a lot of web forms. And a couple of them have HangFire installed because 10 to 12 years ago, it was just a really, 10, 12, 15 years ago, it was a really easy way to get started with running kind of asynchronous jobs inside of the ASP.NET memory space. It was super nice. We didn't have nearly as many tools, containers and cloud functions or Azure functions. We didn't have nearly as much of that stuff, and of what we did have, it just wasn't mature. So it was easy to add this. So I still have to use it, but it's usually not the first thing that I reach for new stuff. Because I do a lot of distributed systems and microservice work, oftentimes I'm looking to create some kind of container, right, that invokes some kind of container to actually do some kind of background process, which we'll talk about. I almost never use HangFire. I'm usually just fine with BackgroundService and adding in that observability somewhere else, usually for it to be seen by a stakeholder, not just some IT person who goes in and just looks at HangFire dashboard, which is fine too. But usually I just add it somewhere in a UI somewhere so that an actual person, not a developer, is actually able to look at it and see that it is or is not running successfully. Let's talk about Azure Functions. Of course, AWS Lambda, same analog, just different tool set, right? Flexible bits of code that can be deployed and run very quickly. That's one of the big sells for Azure Functions, is that it's cheap, starting out, and it's very turnkey to just go in, write some code, and make magic happen, which is awesome as a developer. We want to make magic happen. For background task stuff, if you're triggering something, if it's a job, or maybe it's a request from a message queue or something like that, it's a great way to start off if you're just kind of cutting your teeth on background tasks or moving background tasks more into cloud native services. But you have to understand, of course, that Azure Functions, not only are they very expensive when you get to certain consumption levels, but cold starts are a thing. So you have to take into account that Azure Functions still take a moment to warm up before they execute, if they've been idle for a long time. Here's a very brief example of a timer function. I have a very simple cron expression here to say basically run every 5 minutes. And we trigger the timer function here, and we'll put out there if the next timer is scheduled to run at a certain date time. It's very simple, very straightforward, not a lot to it. You can, of course, have message-based ones if you've never used Azure Functions before, which I surmise that most of you probably have. But, of course, they have HTTP and the ones from listening from a message queue. So same analog, if you just need to move something to be handled to a separate memory space, this would be the place to do it. I do have, for example, I have a simple Azure function that will create thumbnails of images that are uploaded to the web app. So that way it's very simple. That process is disconnected from the main web memory space of the web app. We recently found we were getting a lot of out-of-memory exceptions randomly, and we just decided to move all image processing, and it was just very easy and straightforward to move it to an Azure function, make it Azure Functions problem. And that worked really well. And we haven't nearly hit the cost threshold of where it becomes burdenous to host it, which is nice. A few useful tidbits on Azure Functions, just if you're not aware, if you want to be, you may want to be aware. There's actually 2 execution modes, in process and isolated. TLDR, one runs all of the Azure Functions inside of one process, and one is an isolated process for each. Microsoft is moving strongly towards the isolated model. That is what most, in process will eventually be deprecated and stop supporting newer versions of .NET. So worth mentioning, because there is quite a few differences between the two. So when you start a new application, I think in process is the one that it's the default. If you go to File, New Project inside of Writer, that's what the default was. So just be aware of that. There's a lot of differences, and I won't go them in great depth, mainly because it's not the focus of this talk. But Azure Functions, if you promote them and you find that the cold starts are unbearable, or you just need them to run faster, there is a premium option for Azure Functions that allows you to kind of, like I said, remove cold starts. But it requires a hosted premium instance that starts at 157 USD a month, which then you ask yourself, well, Azure Functions are supposed to be quick and free. Why would I pay for that? As a turnkey way of gaining performance or eliminating cold starts, that might be a thing. But it does get, like I said, Azure Functions, the more you use them, the more expensive they get. This does have a point to all of this, which I will get to here shortly. Do I use these for simple stuff? I absolutely do use Azure Functions. I will reach for them if I need to do something quickly or simply. But oftentimes, it's not a very long-lived process. Most of the time, I will configure a container to just consume generic messages and just have a generic host that might start up, consume a message, and then spin down as things are needed in a message-based system. I like Azure Container Apps for this particular purpose because you can have them eliminate cold starts by having them provisioned and idle for very cheap, as not the 157, but because they're provisioned, it becomes very quickly, they can start handling requests and you don't have those cold starts. So it's kind of the best of all worlds. Cloud maturity is not exactly a good way of putting it necessarily, but it's sort of the natural stepping stone. And it's important when we talk about background processes because Azure Functions can be used and are often used to run background processes. But as consumption goes up, as your needs change, maybe execution time becomes really critical. You may want to move towards premium or even Azure Container Apps if the needs of your app and your system change that drastically. Azure Web Jobs are another option for if you're using Azure App Service. Azure Web Jobs are a way to deploy code out very simply. You just you push it out to the web app as a web job, and it will just run. And it will run either triggered or it'll run continuously. And they run within your Azure App Services memory space, which is fine. It doesn't have to be .NET, which is useful if you happen to need to run PHP or Node or something along those lines. Same thing with Azure Functions. I don't use Azure Web Jobs pretty much ever. If I do use an Azure Web Job, it's because some other service uses it, like Azure Functions relies on web jobs for some of the magic that it does behind the scene. Personally, I just don't use them, but worth mentioning because I know some people do. So for message-based systems, this could be stuff that's microservice heavy or systems where managing compute is a big deal. Again, oftentimes microservice systems have to manage compute really well. So for triggering background tasks, I find for .NET Core specifically that utilizing containers is my preferred way of managing long-running or CPU-intensive tasks inside of a system. So a message goes out on the message queue, and it gets consumed by something. Maybe the Azure Container Service is listening to see if that queue gets a message, and then it will spin up a container instance. Or if one's already provisioned, it'll start it up immediately and get it handling that message. So those are often, because this is the main, like this is a lot of the stuff that I do. Is a lot of these message-based systems. And I think it's important to talk about, and this kind of will wrap up the cloud section of this, because there was a customer that I had a few years ago. They had a very small development team, very small company. In 3 years, they went from like 15 to 20 people to over 100. And I've been there from the beginning as one of their consultants. So I've kind of seen this cloud growth kind of explode, this maturity explode for this particular business. So they're in a specific vertical, and they have to process a ton of audio files. They mainly get audio files, and they have to process to them. They have to listen. They have to actually turn them from speech to text, and then do some machine learning applications on them. This was what they originally had. So you talk about background tasks in .NET. First of all, they went all .NET Core. Because they were, of course, I would not have recommended .NET Framework at all. And of course, I'm a huge fan of .NET. So yeah, let's do the startup in .NET. I love it. And they had a very simple architecture like this. All the tenants were hosted in one database. They had a React front end. They had a Azure Storage as their way of holding those audio files. And they had a storage queue to actually take in messages. And then they just created Azure Functions to come in and say, oh, they use all the Azure bits, right? As soon as a blob hits Azure Storage, you can just program it you can set it up so that it will trigger a function on the other end, trigger a specific function once a blob hits that once the blob hits that once a file hits that blob storage, it'll send a message to the Azure Storage Queue, and Azure Storage Queue will send it over to Azure Functions. It'll pick it up, and it'll handle the message. It was great. They used all of the Azure bits, which made it very turnkey. Of course, there's a thing called vendor lock-in. But in this case, I think they were pretty much dedicated to Azure and .NET, so they were OK with that. So it was very easy. It's very turnkey. That's what Azure wants. That's what Microsoft wants. They want it to be easy for you. Get you in the door. And then they say, yeah, come give us millions of dollars over several years, right? We've got storage queues for messages and blobs for file storage. We've got Event Grid for listening for incoming files. And Azure SQL for stuff that you put in the database. In this case, it was Postgres. But SQL Server would have been had the same problems that they encountered. And then, of course, there was easy-ish observability using Application Insights. Note that Application Insights, comparatively speaking, I don't like it very much. I think it's not great tooling, and it's very expensive. I much prefer something third-party like Datadog, or even you could even host a Grafana instance yourself inside of a container and just receive telemetry from that. So they found as they were growing, they had problems as they were scaled. They reached database limits, which they transitioned to flexible Postgres servers so that they could have sort of bursty performance available to them if the database was getting hit a lot. And they reached their free execution limits on Azure Functions, and Azure Functions became very expensive very fast. It's just the way it goes. They got you in the door early, and then they said, okay, well, we're going to charge you for all that ease up front. And you're like, well, wait a second. No, that's not what I wanted. I thought Azure Functions was supposed to be cheap. No, it's not cheap as you scale. So what they ended up doing was going full bore. If I wasn't part of this particular transition, the decision for this transition. Had I made the decision, I might have done something more akin to Azure Container Apps as opposed to going to straight up Kubernetes, which is what they ended up doing. And that's great if you want to manage Kubernetes clusters. To be honest with you, it is not something that I personally want to do. So they have people for that, which is great. But it's worked well for them. So they actually moved all of the tenant databases to be separate databases so that they wouldn't trample on one another. They had their React front end still. They still have Azure Storage. They still have Azure Storage Queues. They also have an Azure Service Bus for as a more feature-rich message bus solution for their tasks. And occasionally they have a little bit of Azure Functions hanging out here and there, ones that didn't have compute issues. But for all the heavy compute stuff, they went to Kubernetes. This is where they're running their background tasks now. So they've gone full bore. We're not just talking, this talk was never intended to just be like, oh, what's in .NET Core? I think you could figure that out, in 30 minutes of Googling around. It's more, to me, the more interesting problem is the scalability of systems and the reliability of those systems as they scale, and cost management. Moving to Kubernetes was expensive up front, but they realized a 80% cost savings on their compute moving away from Azure Functions. So you see, that's real money. That's real money to a business, and they get better performance out of it as well. So from their cloud maturity, so to speak, they just went all the way from Azure Functions. They just skipped. They might have had premium instances. I don't remember. They didn't do Azure Container Apps. They just went straight Kubernetes. So that's how they ran their background task. And again, it was because they knew that running it in the web space was a non-starter. You could not run it in the same memory space as their ASP.NET Core web API that works with React. Simply because audio processing and machine learning is computationally expensive. So they knew from the beginning that they would have those in separate places. They had them in Azure Functions, which worked really well until, I wouldn't say until it didn't, but it worked really well. But of course, they had to manage those costs at some point. And they did that. I think they did that really well. So let's talk briefly about observability. It could be something very simple as, hey, an AI, some kind of UI checkmark goes when a process runs successfully that a stakeholder or some kind of non-technical person sees. It could be simply stuff it's looked at and babysat by technical people every day. But you still need to be able to look at it and see that it is or is not running. That's important. Could be sending a summary email, right? It could be, like, I have a process that kicks off every week. I wrote it 10 years ago, and they've never, when I worked full-time for this company, I now consult for them, And we've simply just never moved it. It's actually running on a scheduled task, actually. But we know that when it runs and when it doesn't, because it sends an email at the end of its process. That's observability. It's a simple bit of observability, but it's been enough to run it for 10 years, right? Of course, you've got your comprehensive logging platforms like Datadog, New Relic, Application Insights, etc. Which personally, I'm a big fan of Datadog, but it becomes a question of what is your team like and what do you value? What do you value in a logging solution? Some people are fine with text files. Personally, I want something a little easier to search than text files. So how do I do observability? I always just use the basic logging, and super humdrum, super boring, super straightforward, right? I know that it's going to end up, if it's an error, I have something to observe a background process that somebody else can see that, hey, it's not running or it hasn't run, and this thing really needs to run because Saturday we have people coming to class and we need that Zoom meeting created, right? But in the case that doesn't work, of course I've got my logging back so that I can go to Datadog, search for it real quick, and find it right away. I usually just, it's pretty straightforward stuff. I have a logging sync that's configured to talk to Datadog or a text file or application insights, whatever the case may be. And then oftentimes I will report on the health of a process by exposing a health check. And I think health checks are kind of an unsung .NET Core hero. So I wanted to give you a brief demo of them before we close. Let's see. I don't have time for a ton of them. I also didn't show you like a message base. I have a RabbitMQ server running and a client that consumes from that queue and a client that sends to that queue. I won't have time to show it to you, which is unfortunate, but you can see it in the code when and if you download it. So we need to go to, where was I going? It was, shoot. Oh, it was the web app. Yeah, that's right. That's right. Let's go right there. Boom. So we're running low on time, so I don't have a ton of time to go over the code, but I'm just going to show you real briefly kind of what it looks like. This has a health check system built in. This is, again, something that's available in .NET Core. They have a really nice UI that's available as well. And it's basically, I have this background service that runs and says, am I healthy or not? And I have it return a JSON response because I want to be able to consume it inside of that health UI. In this case, it's reporting healthy, but I think it's like it randomly checks every 10 seconds, and yeah, it'll turn unhealthy based on a random variable. And you can button that, it's super turnkey on a health UI, which is super nice, and you can see that this is nice observability. This is a nice way to expose observability. We had I had a situation recently where stakeholders were getting frustrated, like why there's so many of these background processes running. And I said, you lack faith that things are running, and I understand why. So we'll make this health dashboard. I threw this together in a couple of days. I downloaded this library. I threw together the health monitoring in a couple of days to give them that good warm fuzzy, as we say, in America, that things are running and things are working the way that they should be. And if they're not, makes it super easy to see that. So health checks, definitely, if you haven't looked at the health check stuff, definitely check it out. It's super handy for really turnkey, and it's just it's a good kind of system to learn and understand because, again, I do have background services services that just run background services. And I almost always couple them with an HTTP component because I want to be able to at least monitor the health of that thing in a way that an automated system can see it. So, at any rate, that is background tasks in .NET. If you have any questions for me, I'm happy to answer them. You can find me on Twitter. I will be around the conference. You can email me. And of course, the QR code has made its way back. So you can download the code and slice to yourself. As per the usual, I was tweaking them up to the very last second, and I cannot do a good git push right now. So the final version of the slide and the tweak code will be available momentarily. Anyways, like I said, if you have any other questions, come find me. Otherwise, thank you very much.